Now to formalize your notes. At the top of your notes, I'd like you to draw these two triangles. One being a 30, 60, 90 triangle, and another being a 45, 45, 90 triangle. Here's kind of a summary of what we noticed. Across from the 30-degree angle is a side length, and it just so happens that the hypotenuse is twice that length. Across from the 60-degree angle, it's the same length, but with a square root of 3. Those were the observations that we noticed from our experiment. For the 45, 45, 90 triangle, we noticed that these two sides were congruent because this was an isosceles triangle. If this side were x, so was this one, and the hypotenuse was that same value with a square root of 2. Now let's try using some of those triangles to answer some actual questions. What I'd like you to do right now is to copy example 1, 2, 3, and 4. Don't forget the directions, and of course the 4 diagrams. You can try these 4 problems on your own and fast forward to the answers and see if you got them right, or you can unpause the video and go through all 4 examples, your choice. Okay, question 1. The first thing I want you to notice is I put these 2 triangles from our notes right here. You don't have to copy them, but I want them here for reference. I'm going to look at the triangle they've given me, and I know I have to find these 2 missing sides, given that this side is 9. The first thing I should notice is this is a 45, 45, 90 triangle, meaning I don't need this side, I only need this one right here. So here's what I know. If this is a 45, 45, 90 triangle, if these 2 angles are congruent, then these 2 sides should be congruent. That means that G is the same as 9. Now what about this hypotenuse, H? The hypotenuse, the side across from the right angle, is the same as this side across from the right angle. H equals 9 square root 2. I know that because 9 comes from the value of the side, and the square root 2 is a part of my little formula here. How about for example 2? The first thing I want to know is which of these 2 different kind of formula triangles will I be using, the 30, 60, 90 or the 45, 45, 90. Again, I've been given a 45, 45, 90 triangle. That's where I start. So I know I won't be using the 30, 60, 90. Now I need to ask myself what I've been given. Let's see. If 45 is 45, those 2 angles are equal, then these 2 sides are equal. Right off the bat, I know that W is the same as Q. So if I find one, I find the other. I also notice that they've given me the hypotenuse. The hypotenuse value is 8. Now 8 is equal to this value over here. So I'm going to go ahead and put that in red. X square root 2. Now I already know that the hypotenuse is 8, but what I'm really trying to find is these 2 side lengths. And what do these 2 side lengths equal? Well, they both equal x. So now that I've been given this, what I really need to do, let me change my pen color, is I need to solve for x. I'm going to move this up just a little. If I'm going to solve for x, I need to isolate x. So they're multiplying by the square root of 2. So what I'll do is divide by the square root of 2 on both sides. I get x equals 8 over the square root of 2. Unfortunately, I'm not allowed to have a square root in the denominator. So I need to do what's called rationalizing the denominator. So what I'll do is I'll take 8 square root of 2, and I'm going to multiply it by 1, but a really unattractive one. By multiplying by 1, right here, this is 1. Let me show you what's going to happen. My goal is to get the square root out of the denominator. No square roots. Let's see what happens. Multiplying across, I get 8 square root of 2 over the square root of 2 times the square root of 2. Well, that's 8 square root of 2 over the square root of 4. Hey, what's the square root of 4? Well, that's 2. I'm almost there. Now I can simplify 8 divided by 2. 8 divided by 2 is 4. So that's a lot of work to find out that actually that missing side It's 4 square root 2. So W and Q are the side length 4 square root 2. Okay, for this problem, I've been given a different right triangle, one with the angle measurements of 60 and 90. So the first thing I can see here is I'm going to take my bow tie, I'm going to turn it this way. This is the only triangle I need for this shape. So now I need to see what I've been given. A 30, 60, 90 triangle has everything to do with the relationship between the side and the angles around it. The first thing I do is look at the 30-degree angle and the side that's across from it, because that would be x. So I'm going to take my green marker, and from the 30-degree angle, I'm going to find the value that equals x. That means 5 is x. With that, I should be able to find the length of m and the length of t. First, let's look for t. T is the side across from the hypotenuse, right there. The same as the one over here. And it says that the side across from the hypotenuse is 2 times this side, or 2 times x. That means, let me grab my pen here, my purple pen, there we go, that t is 2 times the value of x, which is 5. Meaning t is 10. Alright, now that I found the hypotenuse and the side across from the 30-degree angle as my x, I should be able to find m. I'm going to go ahead and change that color to a blue so we can see it a little bit better. There we go. M is the value across from the 60-degree angle. So let's see what that is here. Across from the 60-degree angle is x square root 3. So m is x square root 3. If only I knew what x was. Wait, I do. X is 5. That means that my m value is 5 square root 3. So the values of my triangle are 5, 10, and our last value was 5 square root 3. Now it looks like a true 30, 60, 90 triangle. One last problem, and I think this one's kind of the most challenging. Again, I'm going to look at my picture and ask myself, what triangle did they give me? It's a 30, 60, 90, so that means I'll be using, let me rotate this guy a little bit. It means we'll only be looking at this triangle. Now to start things off, to make things easier, I'm going to go ahead and color code these. The side across from the 30-degree angle will be red. The one across from the 60-degree angle will be purple, and the one across from the hypotenuse will be blue. Now let's go ahead and identify what we have. Across from the 30-degree angle will be red. So I'm going to take the 30-degree angle. This should be x. Across from the 60-degree angle is purple. This is x square root 3. And across from the hypotenuse is 2x. Where am I getting these three values, x, 2x, and x square root 3? I'm getting them from my standard triangle, my standard 30, 60, 90 triangle. Now what I really have here are three equations. I have x equals a, b equals 2x, and 5 equals x square root 3. Remember, our goal here is to find x, and really only one of these three equations will get me there. This has 2 variables, so does this one. Only this third equation only has one variable, x. So that's where we're going to start. I'm going to zoom out so we can kind of see where we are. Let's go ahead and do some math here. They're multiplying by the square root of 3, so I'm going to divide by the square root of 3 on both sides. That means I get x equals 5 over the square root of 3. And here we have that problem again. The truth is, you're never allowed to have a square root in the denominator. So what do? We multiply by 1. But remember, it's a really ugly looking one. I get it by multiplying by the denominator over itself. Now that doesn't really change my answer because I'm multiplying by 1, and multiplying by 1 doesn't change anything. I get 5 square root of 3 over the square root of 3 times the square root of 3. Well, that's 5 square root of 3 over the square root of 9. I need to move this over just a little bit. That leaves me with 5 square root of 3. What's the square root of 9? 3. Now right here I need to check, can I simplify 5 over 3? No. That means that my x value, that side, right here, my x is 5 square root 3 over 3. So now can we find the sides? Can I find A? Can I find B? Well, A is easy. A is x, and x is 5 square root 3 over 3. That's from here. But how will I find B? Well, B is 2 times 5 square root 3 over 3. It's 2 times my x value. So I'm just going to multiply across, same as 2 over 1. I'm going to get 10 square root 3 over 3. Again, I check to see if these two values can be simplified. They can't. That means that my A is 5 square root 3 over 3. My B is 10 square root 3 over 3. And my hypotenuse, the one that was given to me, or excuse me, not my hypotenuse, my leg, it was 5. So just to kind of show you what the triangle looks like, I'm going to move this over. Last one. So here's my original triangle. This side is 5. This side was x, so 5 square root 3 over 3. And this length was 10 square root 3 over 3. And that makes sense. It follows the same rules of our 30, 60, 90 standard triangle.